Welcome to MathMan's Adventures in Problem Solving. This is going to provide the solution to the problem of the steamboat. It's a distance, rate, time problem that deals with the speed of the boat and the speed of the river. The destination is 30 miles upstream and then 30 miles back, giving a total of 60. I recommend to solve this problem, you use distance, rate, and time for both upstream and downstream, and then systems of equations to solve for the individual speeds. At this point, I'm going to go to a voiceover showing the solution to the problem. So here's the problem. This is a time problem that uses systems of equations. The information is pretty simple and it's very minimal, but yet there's a lot that we can solve with it. One of the things to remember as we're looking for the information is that it's the total trip is 60 miles. So a lot of students might make a mistake and use 60 miles each way, but the total trip is 60 miles. So we have to remember that. Also, one of the other pieces of information is it's going to be 5 hours for the upstream part of the trip, and it's going to be 3 hours for the downstream part of the trip. Now, we can see that there's going to be two different times because we're fighting the current one way and we're riding the current the other way. So we're going to find out the speed of the riverboat and how fast the river is flowing. So we've highlighted the information. The next thing we need to do is we need to define our variables. So we're going to call R sub 1 the speed of the boat and R sub 2 the speed of the river current. T sub 1 is time upstream and T sub 2 is time downstream. And D is the distance either way. Once we've done this, we're going to go ahead and show that the distance each way is 30. It seems like a somewhat trivial exercise, but I put it in here to make sure everybody understands the total trip is 60. Now, each way is going to be the same. Tuscaloosa and the Marina Lighthouse, they're going to be just as far away, upstream or downstream. They're in fixed positions. So now we know that the distance each way is 30 miles. Next, we're going to set up our equation. And this is a distance, rate, time equation. Distance equals rate times time. Now the rates are where we're going to have to create the equation. So we're going to say upstream, the speed of the boat is countering the speed of the river. So it's going to be R1 minus R2, and then T1 is going to be that time it took to go upstream. Now going downstream, the two speeds are working together, so it's R1 plus R2, and T2 is the time it's going to take to return. So here's our equations, and all we did was substitute the values. So first we substituted 30 in each, and 5 hours upstream and 3 hours downstream. Next, we solve for each equation. First, I divided by 5, and then I got 6 equals R1 minus R2. On the other equation, I divided by 3, so 10 equals R1 plus R2. I stacked them on top of each other using the elimination stack method, and they cancel quite nicely because R sub 2 is negative on the top and R sub 2 is positive on the bottom. So 2R sub 1s equals 6 and 10, which is 16. I divide by 2. So now we know the riverboat has a speed of 8 knots or 8 miles per hour. Once we do that, we can substitute into either one of the equations. So I substituted the 8 into the 10. When we solve for that, it's real simple. We subtract 8 from both sides. So the river's flowing at 2 miles an hour. So there's your solution. The riverboat can travel on static water at 8 miles per hour, and the flow of the current of the Tuscaloosa River is 2 miles per hour.
MathMan approves. Please remember to like and subscribe.